Hey guys, in this video, obviously we're going to be talking about some additional practice from Chapter 7. So let's get into it. You're going to have to take notes and work along with me the old-fashioned way. I have attached a PDF so you can have the actual copy, although you need not print it out. You can just work along on plain paper with me. You're definitely going to need a calculator. So first, let's just read through the problem. Local nonprofit organization is hosting their annual casino night fundraiser to raise money for charity. One of last year's most popular games involving the spinner, right over here, and players paid $20. Right, so they paid $20 to spin the spinner once and collected the prize where the arrow landed. Unfortunately, the nonprofit later discovered that this game paid out more money than it took in, which is not a great fundraiser, which is probably why it was the most popular. They wanted to use the spinner again this year, but they needed it to be profitable for the charity and still be attractive to players, like a casino. Okay, so the first thing we're going to do here is create a probability model. Now remember, the probability model has to do with all of the values of x, where x is equal to the profit that the nonprofit took in, and then the probability of said profit. So the first thing we could do here is we could land on $5, right? And so it says, okay, well, the spin lands on 5. And so if you paid $20 and you subtract out the payout, that leaves us with a value of $15, and the probability of that $15 is 50%. Now, what if the spin lands on 20? Well, it looks like 20 occupies about 25% of the value. So 20 minus 20 is going to be equal to $0. So that's the profit. And the likelihood of that $0 is going to be 0.25. Now, what happens if we spin, or if the spinner lands on 50? Well, again, this area here, we're estimating here that this is the same. So this is probably 12.5% and 12.5%, because that's half of 25, right? So we're going to leave that as is and make that assumption. So there's a 12.5% chance that they will lose $30, because if you pay 20, they take in 20, pay out 50, they lost 30. And if over here, if they take in 20 and they pay out 80, they've lost 60, and that's a 12.5% chance. Now again, just taking a look at all of these probabilities here, they're all between 0 and 1. And if you add up 25 and 25, you'll get 50 plus the 50. This all equals 1, so that's good. It looks like our probability model is in good shape. So as you can see, I've already kind of talked my way through B, so I just put a little check there that I have verified that the probability model is in good reality, good standing. Each probability is between 0 and 1, and they all add up to 1. All right. Now we're going to find the average profit. So remember, what we're going to do is take each value of x, multiply it by its probability, and add it to the next one until we have done that for all of them. And that will give us our expected value, or our mean. So the first step has been done for us. We have 0.5 times 15. And if you look at your notes that you've been taking, then you should have that 0 times 0.25 was the next value of x, right? The next profit level, plus negative 30 times 0.125 plus negative 60 times 0.125. And go ahead and figure out that calculation. I'll give you a few seconds here. And feel free, when I'm calculating or waiting for you to calculate, to just press pause. But you should get a value of negative $3.75. So what that is the average amount of money that the nonprofit expects to take in per play. So for every person playing this, if there were thousands of people playing it, on average, they would expect to lose $3.75. Now, had they done their homework ahead of time, perhaps they would have realized that the game was a loser at this point, at least for the cost of the playing of the game, right? So it says describe this expected value in context. And in your reading, you should be heading into the law of large numbers and what that means. So now let's try and take a stab at explaining this. And here we have in the long run, right? And that corresponds to, somewhere around at least 1,000 plays. The law of large numbers, right? So that's the law that we're talking about, suggests that the charity can expect to lose $3.75 on each spin of the wheel. Notice I didn't write negative 0.375 in context. Losing accomplishes the purpose of the negative. All right, so we want to keep this in sort of real life speech. Now, what is the expected value for the profit of the game if they raise the price to $25 per spin? What does that do for us this time around? So what we're going to have to do is we're going to have to redo the probability model. So in an effort to reconstruct this, I'm focusing on the spin. So we have 25 minus $5, so that would leave the charity with a profit of $20. And then we also have 25 minus a 20 payout, a $25 cost minus a $50 payout, and a $25 minus an $80 payout. So what does that look like? Well, all right, just kind of quickly dropping in some lines here. 25 minus 20 would leave them with a $5 profit. A 25 minus 50 would leave them with a loss of $25. And a 25 minus an $80 payout would leave them with a loss of $55. Now again, the probabilities haven't changed. It's chances of landing a 5 is about 50%, or is 50%, 25 and 12.5 and 12.5. So now we got to calculate the expected value, or our mu of x is equal to 20 times 0.5 plus 5 times 0.25 plus negative 25 times 12.5% plus negative 55 times 12.5%. So go ahead and press pause and see if they have an expected earnings at this point instead of a loss. And at this point, if we had a lot of players, it looks like they should expect to make about $1.25 per spin. And you say, well, that's really not a lot of money. Well, if this was a large event, and I don't know, let's just say that, about 100 people, 100 people play, well, 100 times that would give us about $125. Now, it still seems like they might want to raise the bar a little bit on the cost. But as you can see, tinkering around with values and expected values helps people make decisions on how much money to charge for certain things, just like we were talking about the insurance piece the other day. Okay, so now you want to grab this probability model that's partially filled out, and it says here's a partially filled out game with a different spinner that costs $50 to play. So if you spin and win $15, 50 minus 15 would be 35, and 50 minus 30 is going to be $20 profit. And then 50 minus 100 is going to be a negative $50 loss. Now they gave us 25% and 55%, which is 80%. So that's going to leave us with 20 here. And again, this is between 0 and 1. This is between 0 and 1. This is between 0 and 1. All of that adds up to 1. So we're pretty legit on our probabilities. We've filled in all the missing values on the table. To calculate the expected value, we're going to take each value of x, so 35 times 0.25, add that to 20 times 0.55, and add that to negative 50 times 20%. And press pause and calculate that value on your own. Now you should have arrived at a value of $9.75. Now we're going to talk about the standard deviation of the profit for this game. And that gets a little bit more complicated. We're going to do it by hand once, and then we're going to talk about using the calculator. So the standard deviation of this model will be the square root of the variance of this model. And the variance, as we said in class the other day, the variance of x is written sigma squared x, which is variance, is standard deviation squared. So that's how we know that this is variance, is going to be the sum of a bunch of things. So we're going to add up a bunch of things. And first what we're going to do is we're going to take the actual deviation itself. So what we're referring to is the deviation, or the difference each value is from the mean. And then we're going to square all of those differences, and then we're going to multiply those differences times the probability of that happening, and we're going to add all of those multiples up. So the first piece then we have is 35 minus our expected value, right? And our expected value was 975. So we write that right here, and we're going to square that. Now this is our first deviation that we're talking about. Okay, and we're going to square that, and we're going to multiply that times the likelihood of it happening, which was 0.25. And now we're going to add that to the next deviation, which was 20 minus 975, all squared, times the likelihood of that happening, which is 0.55, and add that to negative 50 minus 975, all squared, times 0.2. All right, now let's just take this one step at a time. So 35 minus 975 is going to give us 25.25, and that's still squared times 0.25, plus the 20 minus 975 is going to be 1025 squared times 0.55, and we're going to add that to negative 59.75 squared times 0.2. Now it should be noticed that everything here is getting squared, so we should have no negative numbers on the next line. So what happens when we square $25.25? We get 637.5625 times 0.25 plus 1025 squared is 105. 0.0625 times 0.55 plus, and don't forget, I wouldn't bother putting the negative sign in the calculator, just square 59.75, and you're going to get 3570.0625 times 0.2. And I think I just deviated from who I put the parentheses around, but you get the point. And now we're just going to multiply all of that out, and you should get 931.1875 after you've multiplied and added. Now remember, this is our variance of x. So if you want standard deviation, well, you're just going to have to take the square root of all of that. And so our standard deviation of x is going to be 30.5154. And remember, that's in dollars, so technically we're going to have a standard deviation, oops, it's not squared. We're going to have a standard deviation of $30, approximately 52 cents. So again, just to take note, standard deviation is larger than the mean. That means, 68% of our stuff is swinging all over the place. It still is a large potential to either have a really, really good night or a really, really bad night. So this spinner scenario still seems a little precarious, if you ask me. If someone were to ask me to describe this game in context, using its mean and standard deviation, I would give a line like such. I would expect this game to make a profit of about $9.75 per game with a standard deviation of $30.52. It may not hurt to say something like using the law of large numbers, right, that I would expect this game to make a profit of $9.75 per game with a standard deviation of 30.52 or $30.52. And then that's it. I wouldn't get too involved with saying, hey, they really need to think about this, that, and the other. It's just describing the game, get in and get out. Don't give too much of your opinion unless you're asked for it. Now, depending on who they got to cover for the class, somewhere in the front of the room, there's a stack of papers sitting in a paper holder, um, tilted back. Towards the back side are the stat stuff, the front side's geometry papers. There should be, I forget what color it is, there's two colors there. One says Chapter 16 Quiz A and C, the other one says Chapter Quiz 16 Quiz B. The A and C is what I'd like you to do for class and homework. The other one will be for a future purpose. All right, so that's that. Hopefully this was helpful, and don't forget the homework reading that's also on the syllabus.